Hello children, welcome back to our physics class. In today's class, let us discuss the very important topic in vectors, that is types of vectors. So here we go with the types of vectors. Let us discuss in detail regarding the types of vectors one after the other. First one, it's all about equal vectors. When do you say that two vectors are equal, children? Whenever first of all, we know that what is a vector? A vector is a physical quantity which has both the magnitude as well as direction. A physical quantity which has both the magnitude and direction is called as vector. Now, I would like to discuss in detail regarding the equal vectors. So, whenever these magnitude of both the vectors under comparison are equal and if they represent the same direction, then we say that they both are equal vectors. Okay. So, first of all, equal vectors. So, what are equal vectors, children? Two vectors are said to be equal if they have same magnitude and represent same direction. Let us understand the same graphically. So, let us consider two vectors. So, here vector 1 and another here vector 2. If you compare these two vectors, whether the position of the vector is here, here or wherever be the position of the two vectors, let this be vector A and let this be vector B. So, you can represent this vector anywhere, okay. But if you suppose that on a proper scaling, the length of this vector is equals to the length of this vector, then we say that magnitude of the two vectors are same. And similarly, arrow marker, if they represent same direction, okay, if they represent same direction, then also we say that the vectors are equal. So, these two conditions must satisfy. One is that they must have equal magnitude and they must represent the same direction. So, equal vectors and representing the same direction. But the same vector, suppose if you take like this, its direction is changing. So, at this time you can't say that the vectors are equal. So, if they represent any other direction, something like this, then we can't say that two vectors are equal because direction is changing. Not only this, children, suppose if the length of this vector is increased or something like this, then also we can't say that the vectors are equal. Though they are representing the same direction, their magnitude is different. So, we can say two vectors are equal only when they have say equal magnitude and represent the same direction. So, in this case, vector A is equals to vector B. So, this is all about your equal vectors. Now, let us try to move something, understand regarding another type of vectors, children. Like vectors. So, here only I would like to discuss two cases. One is like vectors and other is unlike vectors. What makes the difference between the two? Two vectors are said to be like vectors if they represent the same direction. Two vectors are said to be like vectors if they represent the same direction, whatever be the magnitude. Okay. So, here if you consider two vectors, one is something like this, another is this. Okay. So, we can clearly say that two vectors are representing the same direction, but their magnitude may be different. Whatever be the magnitude of the vectors, if both vectors represent the same direction, then we can say that they are like vectors. So here, as they both represent same direction, we can also say that they are parallel vectors. Like vectors can be parallel vectors. Okay. So, what are like vectors, children? Two vectors are said to be like vectors if they represent same direction, if they represent same direction, and magnitude can be anything. Two vectors are said to be like vector if they represent the same direction. So here this example, vector A bar and vector B bar are like vectors. So then what are unlike vectors, children? So two vectors are said to be unlike vectors if they represent, if one vector is opposite to the direction of the another vector. So let us consider this example. So if this is vector 1, then this must be another vector. So very clearly we can say that there are two different vectors, vector A and vector B, whose magnitude is different. The magnitude of A bar is not equals to magnitude of B bar, but their direction is opposite. Okay, so we can say that two vectors are said to be unlike vectors if one vector is in the opposite direction of another vector, whatever be the magnitude. So, I hope you understood, children. So, till far we have discussed three types of vectors. One is equal vectors, like vectors and unlike vectors. What are equal vectors? Two vectors are said to be equal vectors if they have same magnitude and represent same direction. What are called like vectors? Two vectors are said to be like vectors if they show or if they represent same direction but magnitude can be different. What are unlike vectors? Two vectors are said to be unlike vectors if one vector represents opposite direction to that of the other vector, whatever be the magnitude. Okay, children. So now let us try to understand the next type of vector, that is negative vector. So all about your negative vector. Suppose if you consider a vector, then though other vector, so let us name this vector as A bar. Let us also consider another vector, say B bar. So, the vector B bar is said to be a negative vector of A bar whenever it has same magnitude but direction is exactly opposite. So, B bar is a negative vector of A bar. Why? Because it has the same magnitude of A but direction is opposite to that of A. So what I'm trying to say is any vector whose magnitude is same but whose direction is opposite to that of the first vector, then we can say that B bar is a negative vector of A bar. So clearly we can conclude that the value of B bar is equals to minus of A bar. The value of B bar is equals to minus of A bar. But magnitude of B bar is equals to magnitude of A bar. So magnitude is generally indicated like this, children. Magnitude means it only indicates the value of that, how much numerical part of it, okay? And regarding, so this is only magnitude. So magnitude of B bar is equals to magnitude of A bar. So B bar equals to minus A bar indicates that both magnitudes are equal but direction is opposite. So next to negative vector, let us discuss in detail regarding the unit vector. This plays a major role, children. So next part is all about your unit vector. So what is a unit vector? Any vector whose magnitude is 1. Any vector whose magnitude is 1 and which has a specific direction is called as a unit vector. So let me write the definition. Any vector whose magnitude is 1, unity, whose magnitude is 1 or unity you can say. Any vector whose magnitude is 1 but having a specified direction, but represents a specific direction. Generally, unit vector is represented by a letter with a cap over it. For example, if A is a vector, A bar is a vector, then the unit vector of A is given as A cap or A hat. It can also be written as A hat or A cap, whose value is equals to given vector upon magnitude of the given vector. So, if A cap is a unit vector, then the value of A cap is equals to the given vector to the magnitude of the given vector. Or from this we can write the value of the vector as A cap into magnitude of that A. So what does this represent? So any vector must follow two properties. One, it must have magnitude, the other it must have direction. So this A bar, modulus of A bar indicates the magnitude of A and A cap indicates the direction of A. So magnitude and direction together makes a vector. So A bar is equals to A cap into modulus of A bar. Okay, children. Suppose if you have another vector, let us consider another vector, say B bar, okay, then which is lying in the direction of A cap only. Then the value of B bar, magnitude of B bar in the direction of A cap. If you consider, for example, I consider some other vector, say B bar, which is lying in the direction of A cap. What does this represent, children? Magnitude. This is different type of vector which is in the direction of A cap. So whatever be the direction of A cap, this will also be having the same direction of A cap. Okay. So a vector which is parallel to A cap. B is a vector parallel because it indicates the same direction as A. Suppose if A is going in this direction, this vector also goes in the same direction. But its length, the magnitude is different. So something like this or more than that or all. Okay. So B bar into A bar is a parallel vector to A. Okay. So it's a parallel vector to A and the vector is given by magnitude of B bar times of A bar. So now moving to the next case, children. Null vector or zero vector. So next case is all about your null vector, or another name is also the zero vector. So what is a null vector or a zero vector? A vector whose magnitude is 0 is called as null vector. I repeat, a vector whose magnitude is 0 is called null vector. Are you getting me, children? So earlier, to define unit vector, we said that a vector whose magnitude is 1, it is called as unit vector, and a vector whose magnitude is 0, it is called as null vector or a zero vector, and it is represented by zero vector, 0, and it is a vector, so bar over that, so 0 bar. So null vector is represented by 0 bar. And remember, children, the direction of zero vector is indeterminate. What does it mean? So we can't describe itself. It itself is a zero vector. It has no magnitude. When it has no magnitude, how can you say its direction? Okay. For this, let us consider a few examples. Let us consider an object at the origin. Let us consider an object at the origin. So this is position of an object at origin. Yes. Let us consider an object at this position. So this is around your x-axis, and here it is your y-axis. And at this initial time, whenever the body is at origin, we can't say which direction is it moving. Is it moving along the x-axis, moving along the y-axis? So nothing can be precise. You don't know whether it is going like this, cross, somewhere, or curved. So nothing can be determined. Okay. So position of the object at origin, we can say that it is a null vector. Okay. Whose magnitude is 0. Whether it is x-axis, y-axis, or any other axis you consider, its magnitude itself is 0. And what about the direction? Unknown direction. So we can't predict the direction of it. Its direction is indeterminate. Not only this, children, one more example you can see. Suppose if you consider a body which is projected vertically upwards. As long as the body goes upwards, its velocity gradually decreases, and at the highest point, its velocity becomes 0. So how much is the magnitude of the velocity vector? 0. So itself is a 0 vector. So now at that highest point, what is the direction of the object that is thrown? Is it moving still upwards or in the downward direction? Is it pointing downward direction or upward direction at the highest point? We can't say, we can't predict. Okay. So a vertically projected body, for a vertically projected body, the velocity vector at the highest point is also a null vector because its magnitude is 0 and direction cannot be predicted. So I hope you understood all regarding your null vector, children. One more properties regarding this null vector you need to know. Always remember that whenever you add a null vector to another vector, it gives the same vector. Similarly, the same vector, if multiplied by a null vector, you will again get a 0 vector. Also, one vector subtracted by the same vector, you also get the null vector. Similarly, if A bar and B bar are two different vectors, and if you add a null vector to it, then it will again gives the same vector, that is A bar plus B bar. So these are the properties of null vector. Okay, children. So now let us try to understand something regarding the coplanar vectors. What are coplanar vectors, children? Any number of vectors which belong to the same plane. Number of vectors that lie on the same plane are called as your coplanar vectors. Okay. So moving ahead with the next one, that is coplanar vectors. So let us consider a plane and let us name this plane as some x and y plane. So it consists only one particular plane, that is xy plane, something like this blackboard. So in this plane we can draw any number of vectors. Let us suppose that vector 1, vector 2, vector 3, vector 4, vector 5, vector 6, vector 7, vector 8, many more. So many number of vectors are drawn in this particular plane, and you can see that all these vectors lie on the same plane. So any number of vectors that belong to the same plane are called as co means same plane, planar, same plane vectors. Okay. So vectors that lie means belonging to the same plane are called as your coplanar vector. Similarly, exact opposite that is non-coplanar vectors. What makes the difference, children? So vectors that lie in different planes are called as non-coplanar vectors. Suppose if you would have drawn few vectors here somewhere, some vectors here on this plane and some vectors let us drop on the floor, few vectors on the wall, few vectors on the ceiling. So we are drawing different vectors on different place. One is on ceiling, one is on floor, one is on board, other is on this wall. Okay, so different vectors are lying on different planes. So those type of vectors are called as your coplanar vectors. And one more thing, children, proper vector you need to know. What is a proper vector? A vector whose magnitude is non-zero. A non-zero magnitude vector itself is called as a proper vector. So remember this, children. So what is a proper vector? A vector whose magnitude is non-zero is called as your proper vector. I'll also drop that. A vector whose magnitude is non-zero. Earlier, zero magnitude means we considered it as a null vector or zero vector, and any vector whose magnitude is non-zero, we can say that it is a proper vector. For example, the magnitude of any vector must not be equals to 0. That's it. So, well, moving to the next topic, children.